rightfully mine. But that aside, you don't know me, you for cuckoo. I say this head bigger than your duku. Stubborn academy, we like to shoot.
Alright, hello everyone, welcome to today's class. So today we are going to be solving a question on equilibrium constants. And this equilibrium constant, we are going to be finding the equilibrium constant for a concentration term and then the equilibrium constant for the mole fraction. Then we are given in the question the equilibrium constant for partial pressure. So how do we solve to get the equilibrium constant with respect to the concentration and with respect to the mole fraction? So now we can see that a reaction is given. So in this reaction we are going to find this, and we have the other parameters like the temperature and the total pressure of the system, and also we are given the gas constant as 0.082 dm³ atm per mole per Kelvin. So firstly, we want to solve the equilibrium constant for the normal concentration. So we are going to make Kc the subject formula. So this is the formula that relates both the equilibrium constant at partial pressure and that at a normal concentration. So if we make Kc the subject formula, we are going to have that Kc is equal to Kp all over RT raised to power change in N. So where this is the gas constant and this is the absolute temperature, and we also have the change in the number of moles. So this change in number of moles here is calculated using the number of moles of the product minus the number of moles of the reactants. So here the number of moles of the product is 2, so that means we'll be having 2 minus the number of moles of the reactant is what? Is 1. So we subtract. So 2 minus 1 will give us 1. So that means our change in N is equal to 1. So we all have the parameters here, so we can substitute. So if we substitute Kp in the question is given as 0.157, then the gas constant here is 0.082. Then we multiply by the absolute temperature, which is 300 Kelvin. So multiply by 300 Kelvin, then raised to power change in N, which we got as what? As 1. So if you multiply this in your calculator, you are going to see that this will give us 6.38 times 10 raised to power minus 3 mole per dm³. So that gives us the Kc value. Now the next question is to find the Kx value to give us Kp all over. So if we divide by this, we'll be having P subscript T raised to power change in N. So this is change in N. So yeah, this represents the total pressure. So we have the total pressure here. So we have this value in the question, so we can substitute. This will be giving us Kp. Kp is 0.157. Then the total pressure is 1 atm. So which we have as 1 atm. Then so we have raised to power change in N, which is raised to power 1. So if we substitute this, we can solve, and this will give us 0.157. So that is the Kx value. So we have calculated the Kc value and the Kx value. So using this relationship between the Kp, Kx and Kc. So in the next video we are going to see more calculations on this equilibrium constant. Thank you.